So hello and thank you everyone for joining. My name is Rachel Montgomery and I'm the Technical Operations Manager for the Product Claims Programs here at SCS. And again, thank you for joining the webinar on Understanding Critical Control Points and Testing Requirements, a Practical Guide. A little about my background. I have been here at SCS for almost 4 years now within the Product Claims Department. And prior to my time at SCS, I have worked in various roles within the food manufacturing industry for about 5 years. I'm happy to be here today to discuss the topic of critical control points and gluten-free testing requirements. So let's get started. Today's webinar will focus on two specific sections of the SCS Gluten-Free Standard version 2.0. These sections include section 7.1, critical control points, and section 10, testing. After a brief review of SCS Global Services and examples of some of the services offered, we will then start by diving into critical control points. We will explore what a critical control point is, how facility classification dictates critical control point requirements, how to identify critical control points, and how to document critical control points. Next, I will review testing requirements, how to accurately create a sample for testing, methods of testing, and lastly, how test results must be recorded for compliance. First, let's start off on some information on SCS. SCS is an international leader in third-party environmental and sustainability certification and standards development. Our clients and partners include companies large and small, associations, government, and intergovernmental bodies, non-governmental organizations, and community stakeholders. Our services include auditing and inspection, verification and certification, training, and consulting. As mentioned, SCS offers various certifications, and listed here are some of those offered within the product claims and food safety programs. Bundling opportunities are available for multiple certifications. If interested, the last slide of our presentation will include contact information for our Director of Sales who can provide information on any of these programs listed. I will start off the presentation with a review of critical control points. To begin, what is a critical control point? As defined in the SCS Gluten-Free Standard, a critical control point is a step in the food production process in which there is a risk of gluten contamination, and preventive measures can be put in place to reduce this risk. Some examples of a step within a food production process where critical control points could be identified include at ingredient receiving or ingredient storage. Now that we know what a critical control point is, what specifically does the SCS Gluten-Free Standard require? The standard requires that critical control points in which there is a higher likelihood of gluten contamination shall be identified and recorded. Why is this important? It's important to ensure that areas that could be at risk of gluten contamination have sufficient measures in place to mitigate the risk. In order to determine critical control points, it is first important to understand the facility classification of the product manufacturing facility. Facility classification will determine the amount of risk that a facility presents to the integrity of the certified products. Higher risk facilities will have more critical control points as there are more areas for potential contamination. There are 3 types of facility classifications, and they include non-dedicated facility with shared equipment, a non-dedicated facility with dedicated equipment, and a dedicated facility. A non-dedicated facility is a facility that handles gluten-containing ingredients and or high-risk ingredients that are not within the scope of certification. There are 2 types of classifications of non-dedicated facilities, those with dedicated equipment meaning gluten-containing ingredients or products do not run on that equipment, and non-dedicated facility with shared equipment, meaning equipment is shared between gluten-containing ingredients or products and non-gluten-containing ingredients or products. These types of facilities contain the most risk as they directly handle gluten within the facility. The last facility classification is a dedicated facility. A dedicated facility is a facility that does not handle any gluten-containing ingredients or any high-risk ingredients that are not within the scope of certification. This slide presents an overview of areas within the manufacturing process flow that could be identified as critical control points based on the facility classification. The box on the left side of the screen shows potential critical control points for a dedicated facility. The middle shows potential critical control points for a non-dedicated with dedicated equipment, and the right shows potential critical control points for a non-dedicated with shared equipment facility. As you can see when making your way left to right across the screen, that the higher the risk of the facility, the more potential critical control points required for identification. Each facility and operation are unique, so depending on the facility classification and operational process, all or some of these listed here may be identified as critical control points. The previous slide showed that the facility classification will be a factor in determining how many critical control points should be identified. But how is a critical control point determined? This slide, as well as the next 3 slides, will show the best practices for identifying critical control points, along with some examples. The first step would be to identify the process flow. Having a thorough understanding and documented process flow will provide a breakdown and visual representation to aid in identification. Step number 2 would be to identify hazards and prioritize them by probability and severity at each step of the process flow. Once the hazards that are identified as most likely to occur and present the highest risk, control measures are created to ensure the risk is mitigated. It is important to note that the SCS gluten-free standard version 2.0 does contain many of these control measures as requirements of the standard itself. The final step would be to implement the control measure and ensure the control measures are effective at mitigating the risk. In the next few slides, we will follow the identification process flow and review some common examples. Establishing a chart, as depicted here with the steps in the process flow, the potential hazard, the likelihood, the severity, and the significance is an effective way of documenting the critical control points. Let's look at a few examples. Example number 1 shows a step within the process flow identified as receiving in a non-dedicated facility. Receiving of ingredients would be a step in every process flow, no matter the facility classification. But for this example, we want to specifically focus on a facility that also receives gluten-containing ingredients. The potential hazard identified is quinoa flour used in gluten-free certified products could be contaminated with wheat flour during the ingredient receiving process. The likelihood determined is that it could occur. The severity of it occurring could cause serious illness for those who have celiac disease. So this has been considered as a significant potential hazard in the process flow. Example number 2 shows a step within the process flow identified as production in a dedicated facility. This step was designed to be generic for this example, as product manufacturing will differ for each facility, but the risk of introduction of contamination from employees is standard across any facility classification. For this example, we have called out that this is a dedicated facility to represent a different facility classification from example number 1. The hazard is that the employee contamination could occur after they eat gluten-containing food on a lunch break. The likelihood determined in this example for this facility is that it could occur. The severity is that it could cause serious illness for those who have celiac disease, so it has also been considered as significant. The significance for both examples was determined with the assistance of the risk analysis matrix, which we will view on the next slide. This slide shows the risk analysis matrix that can be used in determining if a hazard within the process flow is significant. Starting with the row at the top of the chart, you would first follow the chart to determine the frequency of the hazard identified. There are 5 options: common, known to occur, could occur, not expected to occur, and practically impossible. Once the frequency is determined, the consequence of the hazard occurring must be determined. The 5 options to select are fatality, serious illness, product recall, customer complaint, and insignificant. The highest consequence that could occur if the hazard is not mitigated would be the one selected. In the case of our 2 examples, both were identified as C, could occur, as the frequency, and 2, serious illness as the consequence. That means that box number 8 was selected. The number in the box based on the column in the row selected for the hazard will determine if this hazard identified is a significant risk. Numbers 1 through 10, which are the boxes highlighted, indicate significant hazards. Now that the hazards are identified and the probability and severity has been determined, the next step is to establish and implement controls for those hazards that were determined to be significant. So continuing with our examples, we will start with the first hazard identified. Control measures that could be put in place for quinoa flour contamination with wheat flour during receiving include receiving the gluten-containing ingredients at different days or times, labeling the gluten-containing grains with different colored labels, cleaning the pallets after receiving gluten-containing ingredients, and store in separate areas. For our second example of employee contamination after eating gluten-containing food on lunch, controls could include implement GMP policy requiring hand washing when entering production, have a separate lunchroom and personal food storage area away from the product manufacturing area, and require employees to wear gloves when handling product. The final step would be to assign a person responsible for implementing and monitoring the controls. The previous slides and examples we've reviewed show the best practice method for identifying critical control points. The standard requires that these areas be identified and recorded. Some examples of how these can be recorded include the tables that were shown on the previous slides. Can also be integrated with existing HACCP plan or hazard analysis and preventative controls for FSMA. Can be simply identified on a production process flowchart, like the one seen here, or it can be described within a procedure. Testing requirements have been established within the standard as a control or verification measure for applicable critical control points within the production process. The requirements for ingredient, equipment, and finished product testing are determined by risk. This next section will dive into testing requirements, how to accurately compose a sample for testing, and approved testing methods. There are 3 types of testing identified within the standard, which include ingredient testing, equipment testing, and finished product testing. Let's start with ingredient testing. First, what is an ingredient? An ingredient is all materials used in the production of certified products, including processing aids. For example, if making a chocolate chip cookie, some ingredients could be chocolate chips, flour, butter, eggs, vanilla, etc. It is important to again note that processing aids are considered an ingredient and included within the scope of review. Ingredient testing requirements are determined by ingredient risk levels. Each ingredient is assigned a risk level based on the ingredient's agricultural source or derivative. The risk of the agricultural source or derivative is determined by the potential overlap with gluten-containing grains within the supply chain. The 3 levels of risk include low, medium, and high. A low-risk ingredient is an ingredient that has minimal risk of gluten contamination within its supply chain. Some examples could include honey, dairy, salt, nuts, potatoes, and herbs. A medium risk ingredient is an ingredient that has some risk of gluten contamination in its supply chain due to potential overlap with gluten-containing grains or gluten-containing ingredients. Some examples include corn, chickpea, lentils, seeds, rice, and soy. A high-risk ingredient is an ingredient that has a high risk of gluten contamination in its supply chain due to overlap with gluten-containing grains or gluten-containing ingredients. An example of a high-risk ingredient is oats. Documentation that is provided by each ingredient supplier is reviewed to ensure the ingredient is compliant for use in certified products and to determine the risk level. The risk level assigned to each ingredient then determines the testing requirements of the ingredient as detailed in the chart. Low-risk ingredients do not require any testing. Medium-risk ingredients require that 1 test per manufacturer's lot per shipment is tested. And high-risk ingredients require 3 tests per manufacturer's lot per shipment, or 1 for each container, whichever is lower. This will depend on the type of container the ingredient is received in. So for example, if oats are received in 1 truck per shipment, then 1 test is taken, as the truck is the container. If oats are received in 50-pound bags and 100 bags of the same lot are received per shipment, 3 tests are required from that lot. Once the ingredient documentation is reviewed and a risk is assigned, clients are provided with a list of compliant ingredients, which details the risk level for each ingredient as depicted here. The next type of testing is equipment testing. Equipment testing is only required for non-dedicated facilities that use shared equipment. The testing requirement is that 3 locations on the shared equipment are required to be swab tested after a production run containing gluten or high-risk ingredients and prior to gluten-free certified production. The last type of testing is finished product testing. Finished product testing is always required, and the frequency of testing is based on the facility classification as depicted in the chart. For dedicated facilities, 1 lot per month is required to be tested. For non-dedicated facilities using dedicated equipment, 2 lots per month are required to be tested. And lastly, for non-dedicated facilities using shared equipment, 3 lots after production containing gluten, or 2 lots per month, whichever is higher, is required to be tested. For those who sell products as whole seeds or beans, a visual inspection is also required. A 2.5 kilogram sample of each lot of seeds or beans sold as finished products shall be visually inspected to confirm it does not contain any gluten-containing grain. Now that we have reviewed what the requirements are for testing, we will now discuss how to accurately compose a sample for testing to ensure representative results are achieved. Starting with ingredients. Ingredient sample collection is determined by the type of ingredient and type of container that the ingredient is shipped or received in. 3 types of containers have been identified for sampling: bulk ingredients, which could be either solids or liquids, packaged ingredients, and continuous flow containers. For solid ingredients received in bulk, such as in a truck or a wagon, equal quantities of incremental samples shall be taken from at least 5 sections throughout the bulk consignment as depicted. If multiple trucks are received, 1 final sample shall be obtained for each truck or wagon. Incremental samples are then mixed in a container to form an aggregate sample. The final sample shall be obtained by reducing the aggregate sample. So, for example, if a truck is received, 5 different areas of that truck must be sampled. So say you take 1 pound from each of the 5 areas. The 1 pound taken from each area would be considered an incremental sample. The 1 pound samples from each of the 5 areas would then be mixed together. The 5 pound total sample would be considered the aggregate sample. If the test kit or laboratory required a 2 pound sample for testing, 2 pounds would be taken from that aggregate sample, and the 2 pound sample is considered the final sample. For liquid ingredients received in bulk, such as tanks, equal quantities of incremental sample shall be taken from the upper, middle, and lower sections of the tank. In the case of very viscous or creamy liquids, additional incremental samples at different heights are recommended. Incremental samples are then mixed in a container to form an aggregate sample. The final sample shall be obtained by reducing the aggregate sample. For ingredients received in packages, quantities of incremental samples shall be taken from different packages located at different sections within the shipment. The number of packages from each supplier lot to be opened for sampling is described in the table. If 1 package is received, then 1 sample is required to be taken. If 2 to 25 packages are received, then 2 samples are required to be taken. If 26 to 100 packages are received, then 4 samples are required to be taken. And if greater than 100 packages are received, then 10 samples are required to be taken. The incremental samples are then mixed in a container to form an aggregate sample. The final sample shall be obtained by reducing the aggregate sample. So let's take a look at an example. So say you receive 15 50-pound bags per lot per shipment. This would require that 2 bags would be required to be sampled. Say you take a half a pound from each bag. The 2 half-pound samples are mixed together to create the aggregate sample. Then say the test kit or the laboratory requires a quarter of a pound for testing. The quarter pound would be taken from the half a pound aggregate sample to create the final sample. For ingredients received in continuous flow containers, equal quantities of incremental sample shall be taken at the start, in the middle, and near the end of the discharge or charge. This incremental sample is mixed together in a container to form an aggregate sample. The final sample shall be attained by reducing the aggregate sample. Sampling requirements for equipment testing include equipment must be swabbed in 3 different locations, and the locations on the equipment with the most exposure or areas of highest risk of contamination should be selected for swab testing. Finished product sampling requirements for testing include 1 sample of finished and packaged product is required to be tested according to the test kit manufacturer's instruction or external laboratory instruction. It is important to test product that is already packaged to ensure the test results verify that there was no contamination throughout the entire manufacturing and packaging process. For finished products sold as beans and seeds, equal quantities of incremental sample shall be taken from at least 5 sections throughout the lot of seeds and or beans sold as finished product. The incremental samples are then mixed in a container to form the aggregate sample. The 2.5 kilogram final sample shall be obtained by reducing the aggregate sample. Now that we have reviewed what the requirements are for testing and how to compose samples, we will now discuss how the samples will be tested. Ingredients and finished products must test to less than 10 ppm or parts per million of gluten. If selling finished products to a country in which the country's gluten-free labeling threshold requirements is more restrictive than the standard requirements, then the participant must test to the most restrictive requirements. Ingredients and finished products can be tested either in-house by a trained individual using an approved test kit, or can be sent to an external approved laboratory. When conducting testing in-house, a rapid test kit that is AOAC certified and can test to at least less than 10 parts per million of gluten is required. When sending samples to an external laboratory for testing, the laboratory must be either ISO 17025 accredited for gluten testing, or the laboratory must use an AOAC certified test kit that can test to less than 10 parts per million of gluten. Equipment testing can be conducted with gluten-specific test kits or with generic protein swabs. The results of the testing are required to be recorded, and the following information is required to be documented: the name and lot of the ingredient or product, or the name and the location of the equipment tested, the ingredient risk level, if applicable, the date of the test kit name, the test kit lot number, and the test kit expiration date, the person responsible who took the test, and lastly, the result of the test, whether it was positive or negative. We will now take some time for the Q&A session. I will pause for questions to be submitted. If you have any questions on becoming certified or any additional information on this certification, please reach out to our sales director, Ned, whose information is detailed on this slide to get started. So I will pause for a second for questions to be submitted, and I will go ahead and pull those up and we can start the Q&A session. So I'll take a 1-minute pause for everybody to submit their questions. Okay, I have a few questions that came in, so I will go ahead and start answering those. If you think of any questions, please feel free to submit them and we can review those. So first question, if I'm selling product to a country in which the regulation requires that products can only be labeled as gluten-free if they are less than 5 parts per million, what threshold must my ingredients and finished products test to? So as we reviewed, in this specific case, the ingredients and products have to test to the less than 5 parts per million, more restrictive threshold, even though the standard has the threshold of less than 10 ppm. Because the country's regulation is more restrictive, you would have to test your products and ingredients to the restrictive threshold. Okay, number 2. What are the ingredient documentation requirements mentioned, and can testing requirements be downgraded? So this is a great question. So only ingredients are eligible for potential risk downgrade, which could reduce the testing requirements. So if you have a medium risk ingredient, it could potentially be downgraded to low risk, in which no testing would be required. So if you go ahead and source ingredients that are either already SCS gluten-free certified, or if they're certified to another gluten-free standard and that standard requires testing to a 10 ppm threshold, would be a way to downgrade the risk of your ingredients to low risk. So specific information on compliance documentation, it can be located within the standard. There's a section, there's a table 7.5 that details that information. We will actually have another webinar held by SCS this year that will cover ingredient documentation compliance. So if you're interested in a more thorough review, we will be hosting that this year as well. And any specific questions that you have, if you're started in the process, can be addressed by your auditor as well. All right, and the last question that I see so far is, if I have a dedicated facility, would I not have any critical control points because I do not handle gluten? So as covered towards the beginning of the webinar within the critical control points section, specifically, you can take a look back at that chart for a quick reference. But dedicated facilities, essentially their highest risk would be from ingredient contamination from either a supplier or from the trailers when in transit. The other area for potential risk would be from either staff, visitors, contractors, somebody bringing in something gluten containing into the facility. So I think, as previously mentioned, many of the control methods are encompassed within the standard. We do require GMPs, we do require trailer inspection. So that's important to note, but these areas should be identified as critical control points so that staff are trained to focus on these areas. So training of staff on critical control points is a training requirement detailed within the standard as well. I don't see any other questions, but I'll pause for a minute in case anyone has any questions that they'd like to submit. If you think of any questions after this webinar, feel free to reach out to Ned, the contact information listed on this slide, and he will go ahead and send me those questions and I can respond to those as well. All right, it looks like we don't have any more questions that have come in, so I will go ahead and close out this webinar and conclude this webinar. Thank you so much for everyone who joined, and again, you will be receiving a recording of this webinar tomorrow. Thank you so much for joining. Have a great day.